Hey guys, sure. So this video it's just for finite arithmetic series, finite arithmetic series. So and by finite, of course, it clicks, We are not adding up until infinity. We are adding up until a particular point. So this is where we are talking about your Sn. Yeah, well, sum of the first n terms, right? Um, yeah, yeah. So let's cool. And because we're talking about arithmetic series, so it's gonna be a summation of these guys, right? So we'll be summing a lot of these guys. But let's hold on that thought for a sec. Say you have your sigma notation here, 200, right? From say n equals to 1 of n, right? This is going to be 1 plus 2 plus 3 plus 4 plus blah, 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 plus 96 plus 97 plus 98 plus 99 plus 100. Here one plus 100, right? So it's gonna be basically you are adding all the numbers from 1 up until 100. 1 2 3 4 96 97 98 99 100. Then the answer there that you will have is the answer. That will be the answer for this guy. What was I trying to say? But yeah, cool. So this is basically an expansion of this sigma notation when we expand it, right? Now, here's me asking you a question. What is the answer to this question? How do you answer this question? It's a very, very simple question. You don't have to think, right? I mean, you can think really, really hard, right? Trying to find the shortest way to do it, But what I have right now is I'm going to go to my calculator and press 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 8 plus 9, right? Oh, shit. There's a plus missing here. Okay. And so here I just only have 1 plus 1 plus 2 plus 3 plus 4 up until 9, right? So after 9 I need to go again and be like plus 10 plus 11 plus 12. Guys, that's a lot of work. It's a lot of work. And the thing about mathematician, bro, we are lazy. We don't want to do the work, and that is fine because we have ways of actually doing the work, right? Giving the same results with little effort, right? So that's what we're going to try here. We're going to try to derive something that helps us, right? Something that helps us find the sum, right? Without something that helps us find the sum without doing what? Without doing all of this calculating plus, right? Yeah. So first, for this right, for this series, we did say that S100, right? We said S100 is going to be 1 plus 2 plus 3, right? And of course the list, it's a long list, bro. Let me say plus 98 plus 99 and plus 100, right? Cool stuff. And then let me do this. Now I want to add this to another S100, right? But this time around I don't start with 1, I start with 100. So I have 100 plus 99 plus 98, and then this will be 3 2 1, right? Cool. The answer, adding these two, I end up with 2 as 100, right? And here I have 101 plus 101 plus 101. Let's just check. We know it, But let's just check, just to be happy nje. 101, 101, just to be happy nje, right? Plus, right, we did this one just here, 101 plus 101 plus 101, right? What do you see here? You see that when we add this, we're getting 101. It's gonna be 101 through all, yeah, from number 1 to number 100, from term 1 to term 100, right? It's gonna be 101, 101, 101. So what is that saying, what's happening here? So what that is saying is that we can say therefore 2 as 100, right, is going to be what? Is going to be 101 multiplied by 100, right? Because do you realize here that we're going to have 100 of these things? We have what? Cool. Let me see, should I? Yeah. And cool. Now, this 101, remember, we actually got it by doing what? Let me say 100 into, right? We got this by adding 1 plus 100. And of course, we also got it by adding all these other numbers, right? Like 98 and 3, 2 and 99 and stuff like that, But also A and the last value, right? We use the last value and A to get this 100, right? Yeah. So I'm going somewhere here. No? Then I still have my 2 as 100, right? Cool. Now I will say therefore as 100 is equals to 100, 1 plus 100 divided by 2, right? Cool. And then you see here, therefore we can conclude, right, given that all that we have said is true, we can simply conclude what? We can simply conclude that Sn, right, Sn is going to be, remember this 100 is n, we have 100 terms, right? So we have n, right? And here it's going to be A, the first term, plus the last term, which is, right, it was 100 in this case. And then you are dividing by 2. Do you understand? Yeah. Right. I mean, here, of course, you can, okay. Yeah, my mind is like a lot of things. Okay, let me pause for a second on this part. We're gonna come to this man. Perhaps let's finish this gentleman here. Finishing this gentleman, of course, we can say here, your calculator, 100 times 101, it's just here, divided by 2. Yeah, when that simple, you already have it, 5,050, right? That is the answer, right? Cool. Now let me come to this gentleman, right? So I'm gonna do something now, right? I'm gonna do something that is basically going to show that this right here, this right here is the formula we're going to use for arithmetic series. This is the formula we're going to use to find Sn. And so now let us work on that proof. So this one, it was just to give us some satisfaction of, yeah, I want you guys to be happy, not to have any doubts of like, no, but I don't get it. Yeah, well, like when someone is teaching something, you're like, I hear you, but you're actually doubting them, but you're like, okay, I hear you. Yeah, no, I don't. I didn't want it to be like that, so that's why I started with this. So now we're gonna do it a little bit different, right? Let me use which color? Green. I think green is fine. So you have your summation, of course, from, let me say, from n equals to 1, right? And to up until the last term, right? The last term, whatever the last term will be, right? Just remember L here is the last term, right? And then you have your Tn. This is Tn, right? Cool stuff, cool stuff, cool stuff. And basically, if we are starting from term number 1, we're going to L. We are basically trying to find S what? SL, right? So it's the sum to the first L. Yeah, to the first L terms, right? Yeah, cool. So let's cook. Ne? In this case, ne, if we're trying to find SL, right? So Sn here as sum to the first n terms, right? You have the first term, which is A, ne? The second term, what is it going to be? Right? We go here and substitute 2, right? We substitute 2 here. So we have A plus 2 minus 1 D. So the second term is going to be A plus D. Ne? And the third term is going to be what? Here we go, we substitute 3. So you have A plus 2D, right? So you have A plus 2D. Ne? I'll just add the fourth term, but I don't have to. I'll just add it. The fourth term, therefore, you come here where it's n, you substitute 4, and therefore you're going to have 3. So that will be the fourth term. So it'd be like A plus 3D. Right? Yeah. And then plus, continue, and then the last term, right? The last term, I'm just going to say L, right, for the last term, whatever it will be. Perhaps let's do 1 before the last term. Yeah. So I'm gonna write the value which comes right before the last term. So remember now, this is the last term, right? This is the last term, and this is arithmetic sequence. If I want to get the value that comes before the last term, I am going to subtract the last term by the common difference. So here it will be L minus D. Right? L minus D. Right? Cool. I hope you still are, you guys are still following. Yeah. And then let's do exactly what we did last time. Yeah? So it was like, let's add Sn again, but this time let's start with the last term and go zip. Yeah? So you're gonna have L here plus L minus D, right? This is going to be so now we will use L, right? So this is L minus, it's going to be 2D, this one, right? And this one we have L minus 3D, right? Goes on and on and on and on, right? Up until the, I would say this is the last term, and here we have A plus D. You see it, ne? Oh no, this can't be. Yeah, I can either say L. Yeah. I think everything is still fine. Everything is still fine. Do you guys follow? Cool. Yes. I think I am happy. I am very happy. Cool. Everything is fine. I was just checking for errors in J just to make sure, yeah. just to make sure. So then if I add this 2, I have 2 Sn, right? And then I add this 2, I'm going to have A plus L, right? Let me add this 2, I have A plus D plus L minus D, right? So minus D plus D, they're gone. So I'm going to have plus A plus L, right? Plus, I'm on the third one. So I have A plus 2D, 2D, ne? Plus L minus 2D, 2D. And this minus 2D together with this plus 2D, they cancel each other. Then I have A plus L, right? So we've done with this one, we've done with this one, we've done this one. Let's do this one, right? Here it's 3 and then minus 3, which they do cancel each other. So we have plus A plus L. Do you see what's happening? Let me just put my dots, then I'll have plus. Here, if I add the 2, the D cancels, so I have A plus L, right? And here as well, there's no D, so it's just going to be A plus L. Allow me to just leave it like this, right? So what you are seeing here is that 2Sn gives us, we are basically adding this n times, depending on how many terms we have, right? Which is n for how many terms we have. So it's this A plus L, right? Then we divide by 2, and therefore Sn equals to n divided by 2. This plus L, right? So this then is the formula. Beautiful. Look at this. Look at this. Do you see? Yeah. So that is the formula that we use, né? And then of course, we also know, what do we know? We know that L, right? If you want to find L, you're going to use the formula Tn equals to A plus n minus 1D. Right? If you want to know what L is, you're going to use this formula and you're going to substitute whatever L is on the formula. No. Yeah, in mathematics, it's very important how you put certain things, like the words which you choose. So here's the proper word. This is the term value, right? Is the term value, right? This L is Tn, right? It is a term value, not the term number, right? So if we want to find, if we want to find what term number L is, we're going to use this formula by substituting whatever L is, we're going to put it here, and then we find N, right? And then N helps us know when we have L, when we have N and D, we can find L, which is the last term, right? So L is the last term, is the term value. I want to make that clear. So L is the term value. And to find the term value, we use the formula Tn, right? So we can therefore say, therefore, Sn can be also, right, A plus, right? L, I said it is the term value, and therefore we can say, where we see L, we can substitute A plus n minus 1 D, right? Then you have n, A plus A. Oh no, wait, I forgot. Oh yes. Then yes, because yeah, this one is for this one close this one, and this one. Yeah, perfect. So then it's, yeah, and then we still have n minus 1, right? D, right? Therefore we have n over 2 2a, right, plus, let me see, I substitute where we see L, substitute this, I have 2, right, and then I have, so this is just n minus 1 d. Perfect, guys. So yeah, perfect. I'm very happy. So this is, so now you realize we have two formulas now, which are exactly the same. We have this formula right here, and we have this formula right here. Now the question is, when can you use either of them? This one, if you know exactly what the last term is, or you have the means of finding out what the last term is, you can find the last term and substitute that last term here together with the first term, substitute your n, divide by 2, you have your answer, right? But if you don't want to bother yourselves with finding out what the last term is, bro, and in fact you don't even need to, right? Because you have this formula, you don't have to bother what the last term is, bro. You don't have to bother. You just need to know we are adding the first 10 numbers, the first 20 numbers, the first 100 numbers, right? And that n, you're going to substitute it here, right? You have your common difference. Once you have it, you put it here. First value, you have it, you put it there, and bro, the rest is history, man. So that these are the two formulas that we're going to use. This one, if you know exactly what your last term is, use that formula. Don't do extra works, right? Use that formula. And then if you don't know what the last term is, use this formula. Even if you have means of finding out what the last term is, but look, you're trying to save as much time as possible, so use this formula. And so for example, we have this, and they're saying S30, right? So I'm gonna be like, I bet S30 is therefore going to be, I'm gonna have 30 for n divided by 2, right? Then I'm going to have, I can find the first term here, right, and say, so this was just way too fast. So let me find the first term here. I just substitute the first term. I would say 1 minus 5. The first term is 2, right? Yeah, so guys, this one I just jumped in the problem without finding a and stuff, but this is a, go to your calculator, that is a. So we have 2 multiplied by 2, right, and then plus 30 minus 1, then common difference, right? Common difference, remember what the common difference, where do we find it? We find it here, right? This is the common difference, right? Just to make sure that you guys are happy, né? Yeah, so we have 7 minus 5, 1 we get 2, 2 we get 9, 3 we get 16, right? So I'm gonna do this, 16 minus 9, I'm getting 7, right? 9 minus 2, I'm getting 9 minus 2, I'm getting 7. So this is the common difference, right? So then I substitute 7 here, right? And then I just go to my calculator. I'm like 30 divided by 2, right, multiplied by 2 times 2 plus 7 into 30 minus 1, right? Let's see, we have this multiplied by this, gentleman. So this bracket closes this one, and that bracket closes that. Cool stuffs, very cool. So we're getting an answer that is 3105. Do you see it? 105. So if I try to put this in sigma notation, right, it's gonna be something like this. I'm starting from L equals to n equals to 1, and then I'm going all up to 30, and I'm adding t. Now I'm adding 7n minus 5. Ne? So let's see. Shift 7x minus 5. I'm starting from 1 going up to 30. Voila, 3105. Ne? Cool stuffs. So we have another example here, right? We have, look at this, ne? Okay, so because now this video is just mainly arithmetic, you don't have to wonder or ask yourself, is this an arithmetic series, ne? So if we are asked to find, right, summation, if we are asked what's the value of this, they could give it this like this and be like, evaluate the value of this, right? So to get the value of that, we know this is arithmetic, so Sn equals to the formula you use, or you have n divided by 2, right, and then a plus l, right? So first and first, of course, you need to know how many ends do you have, because they didn't tell us in this case, né? So we will quickly find out. I'm gonna remove this. We will quickly find out how many terms there are here. 5 minus 3 minus 1. We just need these two, right, just to find the common difference. Minus 1 minus 3, that is 2. So then minus 3 minus 5, that is 2, right? So therefore Tn equals to I would say n minus 1 d. Therefore Tn is gonna be minus 5 plus n minus 1, and then I have d, which is 2 minus 5 plus 2n minus 2, then that is 2n minus 7. Yeah, I think it makes sense. Let me say 2n minus 7, then I substitute 3 minus 1. So this formula, this is the formula, and we see that the last term is 123, right? So we then say 123 equals to 2n minus 7, 123 plus 7, 2n, 130, 2n, divide by 2, that's 115, 65, 65, let's test it. 130 divided by 2, 65. So n is 65, right? And n being 65, it's saying we have 65 terms here, right? And we are basically finding s 65, right? So you then say s65, you have already written your formula of Sn being equals to n over 30 over 2, bro, a plus l, right? Then you would say here 65 over 2 minus 5, which is the last value, the first value, minus 5 plus the last value, which is what? 1, 2, 3, right? You go straight into your calculator and you'd be like 65 divided by 2, né? And then we are multiplying by, you have minus 5 plus 1, 2, 3, right? 3, 8, 3, 8, 3, 5, né? So yeah, this is the summation, right? So now we know that the last value is 65. We were adding up until 65, and we started from we started from n equals to 1. I want to use the summation, right? The sigma notation now. So we know that the formula, this is the formula, we did find it. It's 2 alpha x minus 7. That is the formula. We started from 1 and we went up to 65. and 3,835. Guys, every time, bro, when everything checks out, I become so extremely happy. But yeah, so we have this one last question. It's very, very interesting question, bro. You could also get it in an exam. So let's try to more this question. Oh, I should also say, you guys, you need to know how to find how to derive these formulas. Now you need to know how to derive these formulas. And the reason I'm saying it's very important for you to know how to derive these formulas is that you could get a question that says derive Sn for arithmetic series, right? I remember getting such questions during my metric time. Yeah, I remember getting a question like that, especially also for geometric. So do know how to derive this formula. So yeah, no calculator, we must evaluate this. Ne? So by no calculator, what they mean, they are saying don't go and do this on your calculator. Right, cool. So this video we're talking about arithmetic series or sequences. You don't have to wonder if these numbers are so, because I'm telling you they are, right? So the first thing first, you have two, let me do this. You have two patterns or two sequences. The first one is 4, 8, 12, right? And then of course it goes on and on and on up until 100. Then the second one is 3, 10, 17, and it goes on and on and on and on up until 101. So this is the numerator, this is the denominator, right? So we're gonna work on them, right? Finding the general rule and so forth, because we need to know. Let me show you the formula. We did say Sn is what is a plus L, or it's 2a and minus 1 d. I forgot the plus. These are two formulas. So for these formulas, look, you need the last term for this one, which we have, so we don't bother for this one anymore. And then we have a, which we do have. We need a, which we do have, but then we don't know how many terms are there, right? So we need to find those. Cool. Sure. Common difference. 12 minus 8, I believe 4. Okay. This is 7. Yes. Right. So we then therefore Tn equals to a plus n minus 1 d, right? And I love this formula, bro, because from step 1 you work it through all out, then the last thing you do, you end up with a formula. Oh, away. So now therefore Tn equals to, we substituting, we have a, which is 4, and we don't know, d we do know, it's 4. Yeah, 4. And then here we can say therefore Tn, right? First number 3, n minus 1, common difference 7, right? So you have 4 plus 4n minus 4. You have 3 plus 7n minus 7. You have 4n. You have 7n minus 4. Cool stuff. But remember, the reason we did this, it was to find how many terms we have in each, right? It was to find n. So to do that, we would say 100 equals to 4n divided by 4, n equals to 25 the side. This side 101, yebo, 101. So 101 equals to 7 minus 4. Then 101 plus 4, 7n, 105, 7n. Therefore, 105 divided by 7, 15. Right? So we have n for both, right? We have n for both. Therefore, we can use the formula of Sn equals to n over 2a plus l, right? So we will then say therefore, right, this, right, yes, let me go for, yeah, this is fine. Therefore this is going to be S25, right, divided by S15 for different formulas, of course, or with different formulas. So we substitute this one. It's, you have 25 divided by 2, the first term which is 4 plus the last term which is 100. Here you have 15 over 2, the first term which is 3, and the last one which is 101, right? So that means you have 25 over 2 over 104, 15 over 204. Shit, yeah, I thought I was gonna have to, because they said no calculator, and me, I'm trying to be like, I'm not trying to cheat, I'm trying to be loyal to the tester. I thought I was gonna have to scratch my head not using the calculator for these, but yeah, 104 and 104, which they divide, right? And therefore I have to evaluate, so I can say therefore S25 over S15 is 25 over 15 over 2 divided by 15 over, which is 25 over 2 multiplied by 15 over, no, 2 over, right? And these, they cancel, right? And therefore the answer is going to be 25 over 15. And look at how it aligns. I was not aware that was gonna happen, right? So yeah, and then I guess because it just aligns, you can then say 15 over 25 over 15, you divide by 5, you have 5 over 3. Wow. Yeah, which is 1.66666666667. Let's see. Yeah, I'm that good, bro. Yeah, so yeah, this will be the end of this video. Maybe just for our satisfaction, yeah, just for us to be happy. And let's do this. So I would say shift, okay, the formula for the S25 is 4x, so 4n from 1 up until 25, right? And here shift, this one, it was 7x minus what, minus 4, right? Minus 4, we're starting from 1 to 15. And we're getting 5 over 3, which is 1.666666667. Guys, thank you so much. I will see you in the next video.